Hello team, in this video we're going to talk about virtual networks. So we have seen that networks are key to cloud computing. Cloud tenants, like cloud customers, they access their resources on the cloud over the internet, like we SSH into virtual machines and we make REST requests to our APIs. Similarly, users access applications through the internet. For example, when we use applications like Evernote or Outlook. And applications communicate through the data center network. Example, when we have east-west traffic. And we need two things from networks in the cloud. We need universal connectivity and we need safe, isolated communication. So let's talk about each of these in turn. So universal connectivity is the property that a virtual machine or a container can communicate with any other device in the internet. And this should consider that virtual machines and containers might be placed anywhere in the data center and across multiple data centers. So universal connectivity is placement agnostic. It doesn't care about where one of the endpoints is located. Also, when we talk about universal connectivity, we assume that the network has high capacity and is available all the time. So we have these implicit assumptions that the network just performs well. And the other property we need is safety and isolation. So here in this example, we are seeing some north-south traffic between a user and a virtual machine on the cloud. So because this virtual machine on the cloud is accessible from external users, we need to harden services running on this virtual machine because this service will be accessed by legitimate users, but it will also try to be exploited by malicious agents, and it will also be open to denial of service attacks on the internet. So we need to protect our application from these external threats. And we do this using firewalls, load balancers, access control lists. We make sure that the software running on our virtual machine or container is always up to date so that it doesn't accumulate vulnerabilities, and we might make security reviews of the code that we deploy on these applications. And we do all this to make sure that the application is not vulnerable to external attacks. However, when our applications communicate between themselves, for example, inside the data center, when we generate east-west traffic, so we have one microservice running on this virtual machine and another microservice running on the other virtual machine, they're going to exchange traffic. So in this scenario, we assume that the microservices cooperate. I mean, we implemented both of them. So it's not like one service is trying to, attack the other one. They're just working together to achieve a common goal. So we might have a less strict security policy in this context, and the containers virtual machines might exchange sensitive information. So when we're talking about internal communication, we are a little bit more relaxed as we're not worried about getting attacked by our own microservices. And because we make this assumption of cooperation between our microservices, we need to be careful about third parties trying to use this to exploit our application. For example, if another tenant on the cloud gets a virtual machine on the same rack as our virtual machines, we don't want this tenant, which might be, a competitor or some malicious agent trying to extract information or crash our application. We don't want this virtual machine to be able to communicate with our service. So, for example, we don't want this, virtual machine to exchange traffic with our microservice on this other side, or we don't want this virtual machine to exchange traffic with this virtual machine. So we want to block this, and this is what we mean by isolation. So the virtual machines in the blue servers, they belong to one cloud tenant, and the virtual machines on the red servers belong to another cloud tenant, and we want to isolate the two of them. To make this a little bit more concrete, let's look at VCM. So VCM is the cluster that we're using to run our code for the programming assignments in this course. So let's consider that this is the infrastructure that the university uses to host applications. So in this cluster, we have 4 virtual machines, and they might be spread across different servers. Our virtual machines can be accessed through the outside world, but only using SSH. So the only thing we can use to access the virtual machines is SSH. And if we want to access a website on the virtual machines, then we need to tunnel through SSH. So SSH is the only external application that we have running on the virtual machines. And this makes it very easy to make the virtual machines secure. Now let's look at the east-west traffic that we have between our virtual machines. So between our virtual machines, they also exchange information between themselves, like this orange line here. But then we have a lot of applications running. So one virtual machine, when it communicates with the other virtual machine, we can have SSH, HTTP, HTTPS, we have Spark running on the virtual machines, we have Hadoop, we have Kubernetes, we have Docker, we have Argo CD, REST API, Jupyter, Flask, whatever we are running inside our containers. So there's a lot going on. So the attack surface over the orange line is much, much bigger than over the blue line. If we were to open all of these applications to the external world, then the likelihood that we would get hacked is much higher. And we actually did by accident in the beginning of the course, and we did get hacked. Just an illustration that it's a big deal to have these applications open to the outside world. So we only open SSH to the outside world, and we restrict the communication between all of these other applications to east-west traffic inside the data center. Now, if another virtual machine on the same cluster could send our virtual machine's traffic like it was in this orange line, then we would be open. We would be vulnerable to attacks from this virtual machine, right? Because on the orange line, we can access all of these applications. So what we don't want is to allow other virtual machines on the same cluster to access our virtual machines. And this is even more important in cloud deployments, because in cloud deployments, we have no idea who's running virtual machines on the same data center that we are. Okay, so to provide this needed isolation, we build virtual networks. And virtual networks, they have an overlay and an underlay. So here you have the physical infrastructure. We're going to run some virtual machines, and the virtual machines come from different tenants. So we have the blue virtual machines belong to one tenant, and then the yellow virtual machines to a second tenant, and the green virtual machines to a third tenant. So these virtual machines will likely exchange traffic, and they will be located on the same virtual network. So let's shade out a little bit the physical infrastructure, and let's focus on the virtual networks now. So these virtual machines, they will be interconnected by a virtual switch. It's like they're all on the same network, connected by a single switch. And virtual machines from different tenants can't communicate with one another. So this green virtual machine over here can communicate with the other green virtual machines because they're connected by this green virtual switch, but this green virtual machine can't send any traffic to this blue virtual machine over here because there's no connection between these two virtual networks. So the virtual networks, they are isolated, and each virtual network has its own overlay. And we also have the underlay. So the underlay is the physical infrastructure that is used to carry the traffic when one virtual machine talks with another one. So when this virtual machine sends traffic to this virtual machine, from the tenant's point of view, it's like the traffic is going through this virtual link and this virtual network. So it's like the virtual machines are communicating directly one with the other. But of course, this is not what's going on in the real world, right? So the cables, they go from the server running this virtual machine to the top of rack switch, and then this top of rack switch will have some cables might go over the spine, but the traffic will eventually get this top of rack switch, and then it will be sent to our virtual machine on rack 2. So this path over the physical infrastructure is what we call the underlay. So we have the overlay, which is this virtual view, and we have the underlay, which is the physical view of where the traffic is going. So now let's consider the case that this green virtual machine wants to talk with this blue virtual machine. And let's consider this legitimate communication. There's some application on the green virtual machine, and it wants to access some service from another application running on the blue virtual machine. Maybe it's a news aggregator trying to get some news from this news provider. So it's legitimate communication. So in this case, this legitimate communication will not go through the data center like any east-west traffic, right? So there's no direct communication between the green virtual network and the blue virtual network. What will happen, the right way of thinking about it, is that the traffic will leave the green virtual network, might go up on the data center topology, and then it will enter the green virtual network as if it were north-south traffic. So from the blue virtual machine's point of view, the request coming from the green virtual machine is just like an external request coming from a client over the internet. So it's a request coming from the outside world. It's subject to all the security policies and the security reviews and the software updates that we deploy to handle external traffic. So even though the virtual machines are running on the same server, when the green virtual machine sends a request to the blue virtual machine, the blue virtual machine treats this request as external traffic. So it's like north-south traffic. So it's easier to secure, and it's going to use external APIs. So we're not vulnerable. The green virtual machine cannot access the internal APIs that the other blue virtual machines can access when talking with this virtual machine. The green virtual machine can only access external APIs.